Okay, so this is the function f of x is said to have a removable discontinuity at x equals a if f is either not defined or not continuous at a, and f of a could either be defined or redefined so that the new function is continuous at a. So basically, we're looking for the way of removing the issue of x equals 5. Since x equaling 5 right now will result in 0 in the denominator, looking for a way to remove that. So the obvious answer would be to just factor the top in hopes that this factor will cross out. So we're looking for a factor of x minus 5. So if I were to factor the top, let's just make the assumption that x minus 5 is a factor of the top. That might just save us some work. So this is going to be 2x, and let's see here, it has to be positive. So we will have negative 10, so I need a positive, this be negative 10x, and I need a positive 16, so this looks like it's going to be 16. So let's see here. If I multiply this out, I get 2x squared plus 16x minus 10x, which will give me the positive 6x, minus 80. So it looks like that's what the top is factored over x minus 5. Now we're able to cross out the factor of x minus 5, which leaves us with a function of 2x plus 16, in which case 5 is no longer an issue because we've removed the discontinuity. So when we plug in 5, we get 2 times 5 plus 16, which is 26. Okay. So now this says evaluate the following limits. If needed, enter 0, 0 for infinity and negative 0, 0 for, or I guess those are O's, for negative infinity. So we're looking for the what the graph is doing as we approach 3/4 from the right and from the left. So you can use the calculator, or you can, plug in values very, very close to 3/4 using the calculator. But I'm going to pull up the graph, see if we can just tell from the graph. So let's see here, clear everything else out. If I plug in, whoops, I have 29x over 3 minus 4x. Zoom, let's see if a standard zoom will do it. So we can assume that this value is the 3/4 where the asymptote is. So it says as x is approaching 3/4 from the right. So if I'm coming in from the right-hand side of the screen, I'm following the graph this direction. Where do the y values go? Well, they tend towards the negative direction, or tend towards negative infinity. As I approach 3/4 from the left-hand side, part B, the y values approach positive infinity. So that might have been, I don't know, an issue with just reading the limits, or maybe it was plugged into the graph wrong. I'm not quite sure. Okay, so this is given f of x equals x squared plus 10x, find the average rate of change. The average rate of change is going to be f of x2 minus f of x1. It's like a glorified slope over x2 minus x1. So if we just let this be x2 and this be x1, we get f of negative 4 plus h minus f of negative 4 all over negative 4 plus h minus negative 4. So f of negative 4 plus h, this is going to get a little ugly, but this is negative 4 plus h squared plus 10 times negative 4 plus h minus f of negative 4. That's going to be 16 minus 40, that's negative 24, all over negative 4 plus 4, that just gives me h. So this, if I FOIL this thing out, I get 16 minus 4h, that's minus 8h, plus h squared. Distribute to 10, I get minus 40 plus 10h plus 24 all over h. Moving right along, I get 16 minus 40, that's negative 24 plus 24. That crosses out with that. Negative 8h and positive 10h is 2h. Oh, and I have an h squared, so this is going to be h squared plus 2h over h. They both have an h in top, so I'm going to factor an h out. I'm left with h plus 2 over h. H is crossed out. I'm left with h plus 2. And the last one, it says there are exactly two values for b which make this function continuous at x equals negative 1. The one with the greater absolute value is. So we're basically just going to figure out what values of b make these two things the same when x is negative 1. So I can go ahead and plug negative 1 into the top and into the bottom and set them equal to each other. So this is going to be negative 2 times negative 1 is positive 2 plus b equals negative 6 over negative 1 minus b. Now it's a matter of just solving this thing for b. So I'll start by getting this denominator out of here. I'm going to multiply both sides by negative 1 minus b. So this, if I FOIL this, I get negative 2. Outer, I get negative b. Inner, I get negative 2b. That's negative 3b minus b squared equals negative 6. I have a quadratic here, so I have to get everything on the one side to solve it, but I don't want a negative b squared, so I'm going to move everything to the right-hand side. So this is 0 equals b squared plus 3b plus 2 minus 6, that's going to be minus 4. So this is 0 equals, this will factor. This is b, b, I could have kept that, plus 4, b minus 1. So I end up with b equals negative 4 and positive 1. Now this is a tricky way to ask it, but it says the one with the greater absolute value. The absolute value of this one is 4. Absolute value of this is 1. So the answer is technically going to be negative 4. And that's your answer.